Experiment to study some oxidation-reduction reactions. In this experiment, we shall study some oxidation-reduction reactions involving the halogens group 7 as oxidizing agents. We shall also study some displacement reactions of metals. All of the halogens act as oxidizing agents. These elements have such a strong attraction for electrons that they tend to remove electrons from other substances. That is, they oxidize other substances. Add about 1/5 of a test tube of chlorine water to the same quantity of potassium bromide solution. Note that the colourless solution of potassium bromide turns orange. This is because we are forming bromine Br2. The chlorine is oxidizing the bromide ion Br- ion to the element bromine Br2, according to the equation shown on the screen. The half reactions for this reaction are also shown on the screen. We can conclude from this experiment that the chlorine displaces bromine from a solution of a bromide salt. This reaction is used to extract bromine from bromide salts in seawater. Add about 1/5 of a test tube of chlorine water to the same quantity of potassium iodide solution. Note the appearance of the reddish-brown color of the iodine. The chlorine is oxidizing the iodide ions to iodine according to the equation shown on the screen. We can conclude from this experiment that chlorine displaces iodine from a solution of the iodide salt. Add about 1/5 of a test tube of bromine water to the same quantity of potassium iodide solution. Note the appearance of the brown color of the iodine. The bromine is oxidizing the iodide ions to iodine, according to the equation shown on the screen. We can conclude from this experiment that bromine displaces iodine from a solution of an iodide salt. Now add about 1/10 of a test tube of cyclohexane to the above test tube. Stopper the test tube and shake it. Allow the layers to settle. Note that the upper organic layer has a reddish or violet color, the color of the iodine solution. The color is almost gone from the lower layer, pale yellow, showing that iodine is more soluble in an organic solvent than in water. In this test, we will demonstrate the oxidizing ability of the halogens by using solutions of chlorine, bromine, and iodine to oxidize the sulfite ion SO32- to the sulfate ion SO42-. First check that the sodium sulfite solution you are given does not contain any sulfate ions. To about 1/10 of a test tube of sodium sulfite, add a few drops of barium chloride solution. A white precipitate forms. If no sulfate ion is present, this should dissolve in hydrochloric acid. Discard the contents of this test tube. To about 1/5 of a test tube of sodium sulfite solution, add the same quantity of chlorine water. Gently shake the test tube and test for the presence of the sulfate ion using barium chloride solution. If the white precipitate does not dissolve in hydrochloric acid, then the sulfate ion is present. We conclude that the chlorine has oxidized the sulfite ion to the sulfate ion, as shown by the equations on the screen. If this experiment is repeated using bromine water and iodine solution, the same results are obtained. That is, the sulfite ion is oxidized to the sulfate ion, as shown on the screen. The final test to demonstrate the oxidizing properties of the halogens is to show the conversion of Fe2+ to Fe3+. A useful source of Fe2+ ions is an acidified solution of iron 2 sulfate. The solution is acidified with dilute sulfuric acid, as this prevents the Fe2+ ion being oxidized to the Fe3+ ion by the air. To about 1/5 of a test tube of acidified iron 2 sulfate solution, add about the same quantity of chlorine water. To test for the presence of the Fe3+ ion, add some dilute sodium hydroxide solution. A greenish-brown precipitate of Fe2O3 is formed if the solution contains Fe3+ ions. The reaction happening is shown on the screen. That is, chlorine is oxidizing the Fe2+ ions to Fe3+ ions. The half equations are also shown on the screen. A similar reaction occurs if you use bromine or iodine instead of chlorine. Oxidation-reduction reactions also occur between one metal and another. For example, a piece of zinc metal dipped into copper sulfate solution displaces Cu2+ ions as copper metal. This may be shown by adding some powdered zinc to copper sulfate solution and leaving it stand for a few hours. We observe that copper metal is deposited in the beaker and that the blue color of the copper ions has disappeared. This experiment may also be carried out by adding some granulated zinc shown on clock glass to some copper sulfate solution. After about 1 hour, note that the pieces of zinc have been covered with copper metal. This is because zinc has a greater tendency than copper to lose electrons, and the zinc forces the Cu2+ ions to accept electrons, as shown by the equation on the screen. Another example that demonstrates an oxidation-reduction reaction between metals is the reaction between magnesium metal and copper sulfate. Magnesium has a much greater tendency than copper to lose electrons, and forces the Cu2+ ions to accept electrons, as shown by the equations on the screen.